In this video, we're going to look at if we had a middle 80% and how that lays out. So if you think of, again, if this is being like 50% all here, then I would have to have 40% on this side, on the left, and 40% on the right. This is kind of just has no values written in on the axis and such, just so you can see, just totally sketch it out, and then we're going to try to figure out what these cutoffs are. So the problem itself is 8D in my open math, so I'm going to go ahead and look at that real quick. So I'm not going through A through C because I think they're more straightforward and people are fine with those, but this one is 8D, where you have the middle 80% of romance novels have how many words to blank words, a lower bound and upper bound. These are the answers here. So I'll show you how you get those using technology. First, we have to enter in the 64,174 as our mean, 17,215 as the standard deviation. Now, because these are algorithmically generated, you may have just a slightly different problem, but it's the same process. So first, I'm going to show you on the little sketch again what that looks like here. So we need to figure out what to enter in for our probability. So we're going to do the left tail. Now in Desmos, I'm going to focus on that one first. You have to use the to the left by using inverse CDF. So that's going to be this little tail. So if this part is 40%, then this part in here would just be 10%, or 0.1 is what we'd enter in. Now to get this other tail would be also 10%, but for Desmos, we need to figure out to the left. So in its entirety, we would have to put in 0.9, 90% would be this whole thing here. Okay, you can kind of figure it out too. You could just take half minus the 40% and get 10%, and then half and add 40% to get the 90%. But setting up the picture is really important when you have these problems that have a center thing going on there. So I'm going to now switch over to the Desmos problem here. Okay, so here's what our Desmos looks like. You just go to desmos.com and use the graphing calculator. This actually should be module 6, number 8D. And we need the middle 80%. So basically you can do the lower percent is always going to be 50% minus whatever half that middle percentages that you're looking for. So that's where we get our 10% that I showed you in the picture earlier. Upper percent, we'd add the 40%, which is half of our middle 80. We want to get that upper bound would be 90%, and we have to put it in as a decimal. So the way we do that is we actually, you can write in normal dist like that and put your parentheses, and then put in your mean and your standard deviation, and then you're going to type in inverse, or you can use the functions inverse CDF. So I'm going to start this here for you. Hang on a second. Okay, so I just typed in my numbers. I could have gone to functions also and accessed the normal distribution right here as well. When you are doing probability, you have to do the inverse thing from when you're putting in values. The values go down here, or z-scores or whatever you're using. But when you have the probability and want to find a value or z-score, you have to do the inverse operation. So we do have to separate them out with a period here, and then you can do inverse CDF or just again type it in. It does look a little odd until you get the whole thing typed. And for that left lower bound, I'm going to put in 0.1 to represent the 10%. And then I get a value here of 42,112. And I'm just going to go ahead and leave that there. The cool thing about Desmos is if I wanted it to show on the graph as a line there, I can do x equals, and that will give me my lower bound on the graph. And then I can also just go ahead and do the same exact thing. You can actually just copy and paste and then change this to 0.9 to get your upper bound, and you get 86,236 when we round off. Okay, so I actually did these earlier too, so I'm gonna bring us up to speed here. And what I did was to verify and to see the graph that I did in fact get the middle 80%. On this one, it's specifically 80%. These are just little text boxes I'm adding in notes. So I'm tracking what I'm doing, and you can see it. If you want to use this as a model, you can. So to get the graph, you would just do the normal distribution, put in your mean, your standard deviation, and then hit this cumulative probability, or CDF, and then I just put in these X values that I got. And I can see here that at 0.79999, that's 80%. And if I want to have the graph show, I can click there and I can see it and verify how it looks, or if I had to draw it out for something, or show it in, document or PowerPoint or something like that. That's what's kind of nice about the Desmos versus GeoGebra. It does a little bit more. You can have everything laid out in one page. I could even do another problem on here. I can turn colors on and off. I can take the graph away. I can take the values away if I wanted to not have those lines show as well. So that is how that works. If you want to add your own little notes, you can do notes here. You can put a table in. You can wrap things up in a folder. You can add pictures. You can write formulas and things like that, like what we did here. If I wanted to add another thing in another row where I would put in the normal distribution or do a different problem, and you can move stuff around too. So it kind of leaves you could just leaves you a good record of what you've done. So I like the Desmos. If you were doing this one in GeoGebra, you would enter the same things in. You would have to put, if it was let's get it to be the left here, I would have to type in 0.1, and then that's where I get my 42,112. So I get the same answer there, and I could type in 0.9 and I get the 86,236. So you get the same answer. You could in GeoGebra, you can actually do it as like the right going up. I think you can just put the 0.1 in like there, and get the same answer. So it is kind of nice. You get that right tail is maybe easier for you to think of it however it works for you, and you're getting the right answers. But one thing with GeoGebra, you do need to make sure you hit the enter key. A lot of times, especially on a tablet or something, it may not actually change what the previous answer was and stuff. So you want to make sure you check that out. And I had already put in the mean and standard deviation ahead of time. You would need to make sure you adjust that with every problem as well. So the same thing with Desmos, but Desmos is, you could do it on a separate line, so you're not necessarily having to overwrite all the time. So I hope that helps. If you have a problem that you're not understanding, maybe show me what your sketch is and what you've tried so far and what you're entering for your probabilities, and make sure you're putting them over in the far right on GeoGebra, because otherwise it's going to go in as an X value if you put it here. If you do it in Desmos, you have to do the inverse CDF when you're entering the probabilities too. So that's a little bit different here. When I do the graph, I'm always entering an X value for this to make the shading. All right, have a great day.